स्टूडेंट्स, बात चल रही है ट्रांसमिशन मीडिया की। हम लोगों ने ये डिस्कस किया था कि ट्रांसमिशन मीडिया exists on layer 0, just below physical layer. In this particular section, what we are going to discuss is the two broad categories that we can divide our transmission media into. So students, on a high level, for you to remember, just consider that when we talk about two broad categories of transmission media, then transmission media can either be wired or it can be wireless. That is as basic as it can get. So wired or wireless. Students, slide पे चलेंगे और हम देखेंगे कि wired transmission media को in the telco or datacom lingo, what do we call it, and what are the different subtypes of that wired or guided media, and then in the case of unguided or wireless media, what are the subtypes for that as well. Let's go to the slide. Students, as I told you, in the first category, we have got guided or wired. That's our first major category. And the second one is unguided or wireless. Students, hum log, for the sake of discussion of this particular course, we'll talk about the three types for the guided media that we are most commonly use and we are most commonly going to encounter in telecommunication and data communication applications. And those three types are twisted pair cable, the TP. There are two further types. We'll talk about that. You probably are familiar with this twisted pair cable as you call it, UTP or STP, and we'll talk about that. Then you've got cable or coaxial cable. Then we've got the fiber optic cable. Students, unguided media या फिर wireless media, we normally use radio waves, we use microwaves, and we use infrared. So we're going to talk about each one of these one by one. Let's start our discussion with the guided media. So students, in the case of guided media, the basic technical definition, the basic definition for your understanding is that guided media is the one which is wired. But technical lingo, the guided media is the media that provides a conduit from point A to point B. Conduit is nothing but a guided path. If you've got a guided path between 2 points and you're using that to transmit information, then we say that our media is wired media or our media is guided media. Students, the basic examples that we have are of twisted pair cable, coaxial cable, and optical fiber cable. Now, twisted pair and coax, you'll see that they carry the information in the form of electrical signals. They've got copper as the primary conductor, whereas in the case of optical fiber, you have got light as the primary conductor, and it's made of glass as the primary conductor in there. Students, the next point is that the signal traveling along any of these media is directed and contained within the physical limits of the media. जैसा कि मैंने आपको बताया कि wireless या फिर guided, unguided और guided में difference ये है कि in the case of unguided, your electrical signals, electromagnetic waves, radio waves, microwaves, or infrared, they are not contained by any physical limits. In the case of guided media, we have got some physical limits and our signal travels within those particular physical limits. It does not go out of those limits. So if we have got a wire, the electrical signal or the light in the case of fiber, it will travel within the physical limits of that guided media. It won't go out. Students, we'll start the discussion of twisted pair cable, the first type of the guided media that we spoke about. Students, twisted pair cable, it consists of two copper wires which are twisted with each other. There is a reason why those two copper wires are twisted, but we'll talk about that in a little bit. For now, you need to understand that twisted pair, the reason it is named twisted pair is because it contains a pair of two wires, normally made of copper, and they are twisted together. Now, students, each of these two copper wires has got a plastic covering, and the plastic covering is also twisted to each other. So think about this twisted pair cable as a pair of copper conductors, each of them covered with plastic. Students, what you need to understand is that in the case of a twisted pair cable, one of the cables, it carries the actual signal, and the second cable, that is a ground reference only. So only one cable carries the signal. Now, students, receiver, when it receives the signal via the twisted pair, it actually calculates the difference between the two. So the signal and the ground reference, it calculates the difference between the two electrical signals that it receives along those two copper wires, and using that difference, it actually extracts the signal that was sent from the sending end. Students, there is a point related to interference, which is noise, and crosstalk. So your twisted pair is impacted by sources around it. If you've got motors, for example, if you've got thermal noise, if you've got impulse noise, such as lightning spike and stuff like that, that causes interference, which is a form of noise, and also crosstalk, if you are, for example, using this in the case of telephone. This interference, it actually impacts our twisted pair cable. Students, the reason the twisted pair cable is twisted is because if you have got two parallel lines which are parallel to each other, then, for example, given a particular source of the noise, it will impact only one of the two cables. If you've got a pair, it will impact only one of the two cables. But because we have got these two wires twisted to each other, what happens is, if you've got a particular location of a noise source, in one twist, it impacts one cable, and then that is balanced out by the impact in the next twist, because now you've got the other cable which is exposed to that particular source of noise. So students, what happens is, because हमारे पास twist चल रहे हैं, in every single twist, if there is a particular location of noise, it impacts only one wire in every single twist. By the time we reach the receiver, and the receiver calculates the difference to recover the sent signal, हमारा जो noise है, या crosstalk है, या interference है, it gets balanced out. If you've got two wires in parallel, and there is a particular location of the noise source, it would have impacted only one cable. But because our wires are twisted, this interference or noise, it gets balanced out, and or cancelled out, and we don't get this interference transferred over to the receiver.